the mic was suppressed in that stream. Ho, ho, ho. Well, that's life. Testing, testing, testing. Okay. Okay. Let's see. Let's see. An OP. All right, welcome, gentlemen. Just kind of take, I take attendances to let you all in. So that's like, that's the delay. We're just about done. Okay. So I hope everyone had a good weekend. Hopefully you were able to enjoy the sights of Atlanta and, just enjoy your weekend, but, still be productive. Let me see if there are any major announcements. So this is the top of week 7. So that means week 8, we can anticipate exam 2. It should become available on Wednesday. Let the student in. It should become available on Wednesday. It'll be just like exam 1, where you can you can anticipate an online component. Sorry, I'm going to suppress my audio so I can focus. So you can anticipate an online component and an oral component, right? So I want the oral component to be like 20% of your grade of that exam. And basically what I would need on your end is just to be able to see your face. And then, I need you to answer just 3 questions from your assignments. I just need to be able to see your face, and you'll see my iPad screen. and you just tell me what to write, right? Um, it's just for me to get a sense of where you guys are. Good afternoon. Let me see if there's anything else. Yeah. So again, just as a reminder, my intent is to use this time period as like a study session, right? So, the original intent is for this to be like a Q&A. If you have questions about the homework or just any other thing, now is a good time to get those. This is the ideal time to get those things resolved. Also, as a reminder, or as a alert. So, like if you email me and if I just don't reply by the next class, then just ask me during class time, right? That's so this is really office hours because the way this class is set up, we actually get a lot of extra, like a lot of downtime during class time. And so instead of trying to schedule like office hours and then it's a clash as far as the scheduling, I just did it during now because I know that you guys are available, and because we get a lot of downtime during class. The way everything is structured, right? Um, so what I've been doing with the students as of late, I've been going back through the questions, like the homework questions. But what I did, I basically made an assignment that has all the possible questions that could show up on the exam. It's not available to you all, but we've been like going through line by line and saying, okay, trying to see if we can find questions that are not necessarily assigned in the homework, but that could pop up on the exam. Because that's what I did with the exam. Basically, what I did is like I took all any question that the thing could ask from 1.4 to 1.6, and then I pooled like certain questions together, right? And so there's a good chance you'll see questions on the exam that were not necessarily assigned in the homework, but the content is the same. It's still the same material. You should be able to handle it. You might have to think a little bit, but I'm trying to see if we can kind of tackle some of those before they pop up. I think my last class just did not stream. I tried this. I thought it was streaming, but I couldn't find the video. I don't think it streamed. And then I think my class from this morning, the microphone may have been muted, so I don't think it caught the audio. So you might be the first group today that like had a successful stream. Um, but yeah, so like we don't have to work on any the questions that you see me working on. We can go to others, but otherwise I just kind of go in order because you guys are kind of quiet a lot of times. But it's okay. It's totally okay, except for on my exam. So again, I did go ahead and suppress the audio. If you have questions about anything, just type it in the chat or feel free to raise your hand, your virtual hand. Let me check the chat. I see there's one thing. No, no, no. So the exam was going to open up a week from this Wednesday, right? Also, I just want to remind everyone. Okay. So all the homework for the entire semester is already available. You can actually finish, like if you finish all those assignments that are already there, you'll be done with at least the homework for my class. The quizzes for the entire semester are available. They've been available for a few weeks now, right? So if you wanted to go ahead and finish those, you can, and you'll be done with the quizzes. The only thing that's not available in advance are my exams, right? So I think we did exam 1. That is available. You get unlimited attempts on all assignments, even the exams, even all the way until the end. It's just that after the due date, there's a 10% late penalty. So if you want an A- on any exam, you just got to get, or any assignment, you can get it, right? I think this group has a a lab component, so just be sure that you're working with Dr. Lamar and just doing the things that she requests of you, and she gives me reports on like what you guys are doing. Yeah, and the exam opens a week from this Wednesday, and it'll be due the following Monday at 9 a.m. These are good questions. Okay. Oh, let me get this student right here. Okay. Let me see. So we are moving into October, right? That's so sad about the Morehouse homecoming, man. I'm like, that's like, you know, it's just nice to go to those things and see that the school is doing well, and to cancel it, that hurts. Um, what was I about to say? Oh, and the second Sunday of every month is like free admission at the High Museum of Art. So it's not this upcoming Sunday, but the following Sunday is free admission. So like if you just wanted something free to do, it's like on off of a block south of 17th Street on 16th Street. It's just something that's nice and it's free. So I just encourage the students to check it out. Okay. Let me check one other thing. Testing. That looks good. Okay. So let's see, where do we leave off? So this question, it comes from section 1.4, question 65. It says the graph to the right shows a particle moving on a coordinate line with a velocity v equal to f of t at some time t seconds. Find the domain of this and interpret, right? So this is the graph, shows a particle moving on a line, and we have a velocity. So we have time versus the velocity. So like when the time was 0, the velocity was 0, and then as time progressed, it sped up, it flattened out, it slowed down. It may have changed directions because it went into the negative, right? So it probably changed directions. Let me get this student right here. Okay. So let's see the domain. So in a graphical sense, the domain is the very left to the very right, right? So domain, the far left, in this context, the far left looks like it's going to be 0 seconds, and the far right looks like, let me see, 21, 2, 3, 4, 5. So it looks like 23 seconds. So the domain in this case looks like it's going from 0 to 23. Let me finish out this question, then I'll check the chat. An interval notation, so it looks like it's going from 0 to 23 seconds. And it looks like we touched those, so I'm going to use square brackets because we can include those endpoints, right? So I'm going to hit enter. Okay. So the particle's motion is tracked from -2 to time 6. No. It's from 0 to 23 is yes. The time, indefinitely, no. Particle takes on all velocities, no, right? So the particle's motion is tracked from the time t equals 0 to time t equals 23, right there. So B is the one that looks correct. Oh, that was it. Okay, let's check the chat because I know there's something going on there. The midterm is a week from this upcoming Wednesday. Sure, go ahead. Let me see. So the way I do attendance, we are doing online asynchronous. So what that means is, all I need from you all at any given session, each time we meet, just check in. Once you get into my Zoom, you've gotten your attendance credit. So I know you see a grade populating on Blackboard. That grade for attendance has nothing to do with anything. Every time we meet, I say who's here, who's not here. Like if you get into my Zoom, you've gotten your credit. The only time attendance becomes an issue, like once we rack up about 3 and definitely at 4 unexcused absences, then you could be withdrawn from the course and it could mess up your money. So I really just use attendance as like record keeping. So when the administrator is like, hey, when was the last time you saw so-and-so? Oh, well, my records show that the last time they were in my Zoom session was this day, right? But because this is asynchronous, again, all I really need you to do is check in each time, at least get into my Zoom so you get your attendance credit, and then, you're free to go from there. And I just do that because, like, I understand the thing with like the technical difficulties and stuff like that, and so, it's okay. It's totally okay. Yeah, it's next week, a week from this Wednesday. Yeah, a week from this Wednesday. Not this Wednesday, but a week from this Wednesday. Okay, good questions. Okay, let's go into the next one. So that one wasn't as bad as it could have gone some other directions, but it didn't. So I was like, okay, let's try another one. We got, how many questions are in this thing? This kind of goes on for a while. Let's work this one. So it says the table below shows a recent state income tax schedule for individuals filing a return. We have this chart, right? I'm just let the chart be. Okay. So then we have this piecewise function. It says write a piecewise definition for the tax due on an income of X dollars. Okay, so if the income is between 0 to 15,000, which is the first line, it says 3% of taxable income. So the tax due is 3% of their taxable income. So if X is their taxable income, then the tax due is going to be 3% of that. So we write that as 0.03 times X. Okay. So then the next one, if their income is between 15 to 30,000, that's the second line. It says it's 450 plus 5.5% of whatever's over 15,000. Okay, let's think about this. So if you want the amount over 15,000, you want to say X minus the 15,000. All right, I'm going to put that in parentheses. So that captures the excess over 15,000. Then we want to take 5.5% of that. So 5.55% as a decimal is 0.055, right? So we want 5% of the amount over 15,000, and then plus this 450. So I'm going to come over here and put plus 450. So that's that expression where it's not simplified. We do need to go back and simplify it. And I'm going to go ahead and do something similar for the third part. It says the 1282.50 plus, so it's basically the same formula. You just got to change the numbers. 0.065 times, we want to say x, we want the amount over, so we're going to say minus 30,000. 30, 1, 2, 3. We want to say plus that 1282.50. Okay? So before I submit this, I need to simplify. For instance, for that line 2, if I distribute that 0.55 and combine like terms, I'm going to use my calculator. So let's go here, clear. So for instance, I'm going to do 0.055 times 15,000. I get an answer. Then I'm going to say plus 450, right? Because I'm basically combining like terms. I get 1275. Actually, no, I need to back up. I should be writing it out. I'm trying not to. So let me back up. I ignore the negative, right? So I need to incorporate that negative. So if I say 0.055 times 15,000, but it's a negative 15,000, we get a negative result. And then I'm going to say I get a negative 825. Then I'm going to say that answer of negative 825 plus 450. Okay, so then we get minus 375. So after we distribute that 0.055, we get this minus 375. We've accounted for all of these items, so I'm just going to get rid of them. I should write this out, I just didn't. So if we take what we had before, we do our distributing and simplifying, combining like terms and all that jazz, we get to this point. And I'm going to do something similar for the third line, right? So what I'm going to do, I got my 0.065 times 30, the negative, 1, 2, 3, the 30,000, but it's negative. So result after those operations, I got negative 667.5. Okay. The rest of these we've already used. So I'm gonna clear them out, and we're done with this parentheses as well because we distributed that 0.065. Okay, so we saw the construction of these expressions in the piecewise function, and then we simplified it. I kind of did it audibly. Okay, I'm gonna check my result. Let's see. Blah, 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 blah. It says your first and third answers are correct. The second one is not. Okay. Let's go back. 5, 5, 5, 6, 15. Let me redo it. Maybe because I feel like we just typed something wrong. So excess over 15, right? So let me kind of go over here, and I should be writing this all the way out. Let's see. So we got 0.055 times. Am I out of space? No. Times, we're going to have this x minus 15, 1, 2, 3, right? X minus 15,000 plus 450. Okay. Let me put this in my calculator one more time. So let's see. If we distribute the 0.055, we're going to have 0.055 times 15, the negative 15,000. Okay. We get an answer. Then I'm going to say plus, I get a negative 825 plus 450. I still get my negative 375. 5%, 450, excess over. What am I missing? Missing. I'm not seeing anything different. 375, 0.055x. I'm not seeing anything different. Let me think about it some more. 375, 15. Okay. 2 in the waiting room. I'm trying to see if I can find where I made my mistake. Because it says that the first and third is correct. I can't see 450. I can't really see where I'm making a mistake on that second one. Oh, I found it. Okay. I found it. I wasn't putting enough fives. I only did 5. I did 5.5 instead of 5.55. That's what it is. I knew it was something with that. Okay. So we need to go back. Okay. So I think I was like, let me kind of put stuff back. So for instance, what I'm saying is the following. So I was putting, let's do it like this. In my calculator, I was putting 0.55. It should be 0.555, triple fives, right? That's what it is. So we have this 0.0555 times, there it is. We get this x minus the 15, 1, 2, 3, okay? And then plus 450. Let me go back because I just was missing that extra 5, right? Okay, so now let's account for these changes. I think we found the error. It's clear. So now if we distribute the 0.0555, right? We're going to have 0.0555 times 15, 1, 2, 3, and that's a negative 15,000. We get an answer. I get an answer of negative 832.5, and then we're going to say plus 450. Okay. So now I'm about to let these students in. Now I'll get a negative 382.5. So this should change to negative 382.5, right? And then I think we can get rid of everything else. So yeah, I was just missing that third 5. That's what was going on there. And see, even here, right there, it's 555. 0.0555. Okay, I think that was it. Let's hit enter. Cool. So that was the thing that we were missing. Let me see. I know we got some students popping in. Let's see. This one. And this one. Okay. And I think, let me see. I know there was some activity. Oh, no, there was no activity in the chat. Okay. So yeah, we found the mistake. We got to the bottom of it. We just were missing a 5. We got the concept, but we were missing a 5. Determine the graph, right? So 0 to 15,000, it has a positive slope of 0.03. So this is in the form of like slope-intercept, y equals mx plus b. So notice the slope gets steeper and steeper. Let's see, 0 to 15. So it should change at 15. I think all of these change at 15. Then it should change at 30. At 30, for instance, but not over. So say we were at like 30,000. If we put 30,000 into our expression, that'll give us one of the points, all right? So let me just put 30,000 into that second line to see what the number looks like. So for instance, when x, so if we do 0.0555 times 30,000 minus 382.5, then we get taxable income is, or the tax due is 1282.5, right, at 30,000. So at 30, it should be 12, right? This is well beyond 12, so it can't be A. At 30, it should be 12. B looks a little high at 30,000, so I don't think it's B. C should be 30 and 12. 30. So halfway is the 1250. It should be closer to half. D looks the most promising. I think C didn't even change at the 15, like it changed, like these numbers aren't aligning properly. D looks promising. It changes at the 15. 30 was the 12. And we can like choose a few other points to make sure that they work. Like if we choose something above 30, you know, it should give us like about 14. But D is the one that looks like it's the closest to what's going on, so I'm gonna go with that one. Okay, let me check the chat. Good afternoon. Okay. All right. We're hanging in there. I'm like starting to fade. I always start to fade like when it gets later in the day. Find the tax due on the income of 32,000. All right. So if we're doing 32,000, that means we need to use the last line. So we just plug 32,000 into the last line. Okay. So we're going to say 0.065 times 32,123 minus 667.5. Tax due is 1412.5. Nope, got to go back. I did a flat 32,000. Let's try that again. So if we're using the third line, 0.065 times, it's not 32,000, but it's 32,642, right? That's what we were missing last time. Okay, and then we got to say minus 667.5, minus 667.5, okay? So now we get 1454.23, and it says round to the nearest cent. Yeah, so let's go with this. We got 1454.23. Okay. Ooh, guess I'm getting old because like now I just want to take a nap. I'm so sleepy out of like nowhere. Okay, on to the next question. I think the chat is kind of quiet, so I'm gonna just kind of keep moving. Let's look at this one. We have, let me see the string. Ali accent free. Okay. So Kara's custom tees experience fixed costs of $500 and variable costs of $2 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's custom tees. Let X be the number of shirts and let C of X be the total cost of producing X shirts. Then calculate the cost of producing 5, right? An equation that can be used to determine the total cost is the following. It says that she experienced a fixed cost of $500 and a variable cost of $2 a shirt. So 2 times X plus 500, right? So the fixed cost is like the startup fee, like what it costs to start the business, whether she produces a shirt or not, just to be in that business is at least $500. And then it costs $2 per shirt, right? So she produces, like if she's just to get in the business and she produces 0 shirts, notice when X is 0, you get 500. If she produces 1 shirt, she still has her fixed cost of $500, but then and it costs $2 per shirt. So when you plug in 1 in, you get 502. You know, you just check a few to just make sure that makes sense. Like think about what it should cost, and then you test it in your equation to see if it works, right? Okay, let's go with this. I'm gonna hit enter. Okay. The cost of producing 5 shirts. So if we plug 5 into this, 5 times 2 is 10, so then 510. 510. Boom. Okay. Again, if anything is not clear, if I need to go back, just type in the chat, get my attention, and we'll go back. Okay, it says click the reset button in the upper right corner and check the show summary box. Select each indicated function with the select function menu and determine which of the following is not even a function. Use the interactive figure to find your answer. Which of the following is not an even function? Click here to launch the interactive. Expired, login. Oh no. Is this? I might just skip this one for right now. Even. Okay, now if we wanted to test this algebraically, even means whenever you replace x with negative x, you get back the original, right? So like for instance, let's start with C. If we replace x with negative x, those negative x's, because the powers are even, those negative x's become positive, so it goes back to the original. So C is definitely even. B, if we replace x with negative x, and then we take the absolute value of negative 4x, we get positive 4x. It's not A, because if you plug in negative x, again, the same kind of argument as part C. You square a negative, it goes back to the original. Absolute value of a negative is positive, so they are equal. So that's why I'm saying it's not B. But with D, with these odd exponents, that's gonna create like obscure negatives where you can't get it back to the original or some form of the original. So the one I'm gonna go with is D. Okay, I am fading, guys. It's like we got a solid 10 minutes. Uh-oh, what did I minimize? Something I didn't want to minimize. This one, right? Okay. Okay, I'm not gonna worry about it. I saw some activity, but I don't see what I was looking for. Okay. Let's try another one. Okay, so this one, they want us to do the interactive figure. I'm going to bypass it. It says, which of the following is an odd function? So odd means, in the algebraic sense, if whenever you do f of negative x, you get negative of the original. Okay. So part A is odd, right? If we replace x with negative x, the bottom goes back to itself. The top becomes negative 25x. You can factor out that negative and you'll get negative of the original. So A is odd. I just want to verify that the others are not. Again, odd means when you replace x with negative x, you get negative of the original. So, and it says which one is odd. I'm just going to go with A because we did verify that that is indeed odd. Okay, let's see. The point blank will also be on the graph. Let's see. It says check the show summary and show coordinates boxes and select the even function. We have this. Move the x slider to compare the coordinates of the display. So let's see. This question is okay. Is this even or odd, right? This is if we replace x with negative x, I think we get back the original. So that means this function is even, which means we have y-axis symmetry. If we have y-axis symmetry, then whenever we have x comma y, we also have negative x comma y, right? So if this is symmetrical about the y-axis, since we have this negative 2 comma 5, we should also have 2 comma 5, right? We just changed the x's. 2 comma 5. That feels like some kind of relationship advice. Change the x's. I don't know if that's good relationship advice. Like, what do they mean by change the x's if there was a relationship? Like, go from one x to another x, or move away from the x's. Anyway, a little bit of humor. My energy is shot. Okay, let's see. It says, okay, select the even function. This function is even. Move the x slider. Okay, if this is on the graph, so we're given that this function is even. I'm just, you can verify the definition. We're also given this point 2 comma negative 15. So if 2 comma negative 15 is on the graph and the function is even, then negative 2 comma negative 15. Just the x's changes. Negative 2 comma negative 15 is also on the graph. Okay. Okay, we're given that this function is odd. Okay, so odd means whenever we do f of negative x, we finish with negative of the original. So also another way of articulating odd functions, whenever you have x comma y, you also have negative x comma negative y. All right, so both of them change with the odd. So if this function is odd, then that means the point negative 1 comma negative 8 should also be on the graph. I changed both the x and the y. With odd functions, both x and y changes. With even function, just the x's change. Okay, it says that this function is odd. Okay, we kind of discussed this one already. So another point, so if we have this -3, -7, and the function is odd, with odd functions, whenever you have x, y, you can change both. You can change both the x and the y, and that new point will be on the graph, right? So that means, in this case, we're also going to have the point 3, 7.5, because they both change. Ooh. Okay, let's see. The function is increasing over what interval? Now, if we can't get this interactive graph to work, I can answer this question. Okay, I'm at least have to be aware of that. The function is increasing. We only have the image. Okay, I can't see the numbers. It's increasing from here to here, but I don't really know what those corresponding x values are. It looks like maybe 1, 2, 3, 4, 5, 6. Maybe 1 to 6. Let's try 1 to 6 and see what happens. If we get it wrong, I mean, because we can't see the graph. Increasing, so we use parentheses. I'm going to put 1 to 6 and see if that works. Oh, wow. Okay. All right, I'm going to let that be. Next question. Let's see. Choose the correct. Okay, x slider define various functions for x strictly greater than 2. On the interval, it says on the interval in which f is increasing, x2 is greater than x1, and which of the following is true? Okay, if the function is increasing, whenever x2 is larger than x1, then f of x2 should be larger than f of x1. If it were decreasing, whenever x2 is larger than x1, then it's the reverse. All right, but increasing, I think it's a direct correlation. Okay, so it says on an interval from 1 to 6 in which f is increasing, if f of 3 is 9.5, then which of the following is true? F of 2 is bigger than 9.5? No, because it's increasing. F of 2 should be less than 9.5, right? Because increasing kind of follows your intuition. So since the x is smaller, the y should be smaller. I'm going to go with that. Okay, so then over what interval is the function decreasing? Interval notation, right? So we said that was what, 1 to 6? So then it should be decreasing. The far left, it looks like the far left is what, negative infinity up until 1. And then I'm going to put cup, so that means like that's union or combine. It's also decreasing from 6 to infinity. So basically I chose, let me think about it. Decreasing, function is decreasing over the interval, negative infinity to 1, and then 6 to infinity. Only other thing I could think is take out the cup and put a comma. Let's try one more time. Let me think about it. Unless this is a different graph, but I can't see it. Should be decreasing from negative infinity up until 1, and then from 6 to infinity. Unless it's not a 1 and a 6. I'm not really sure. I might have to get this one wrong. Let's go cup. We tried this. Let's see. What is this? It says, I can't see. I'm not sure what that says. I'm just going to see what the answer is. 2 to infinity? Yeah, I would challenge. It says it's decreasing. 2? Is that a 2? Well, that might be why. me think about this. Because we can't see it, so that could be a 2. But it should account for this part on the left as well. Select the decreasing bullet and check the interval and function values. Over what interval is the function decreasing? Use the interactive. The function is decreasing on this interval. 2 to infinity. It might be because we might not be looking at the proper function. So I just want to kind of go on to the next one because we can't see it. Because like when I try to open, I get like a error. And it could have changed on us. Let me see. 2 to infinity. Function decreasing. Let's just try 2 to infinity and see what happens. Again, it's just because we can't see the graph. Okay, well, that's essentially the time. Let's try one more. Use the slider. Choose the correct. Okay. So on the interval on which the function, so when the function is decreasing, whenever x2 is bigger than x1, then f of x2 should be smaller than f of x1. Because it's decreasing, it's the reverse of your intuition. All right, so I'm going to go with C and hit final check. Okay, that's more than enough for one day. We can stop there. I don't think I wrote anything for you all. Nothing popped up that I needed to write. So if there aren't any burning questions on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right, I'll see you again on Wednesday.